Let's now tackle the third and last problems of recursions on strings. And let's now see what a method should do. So write a method that will take a string as input and also a character C as input. So there are two inputs for the method. And then you want to count the number of occurrences of the number of occurrences of the character in S. That will be the problem. All right. I'm pretty sure you know how to solve this problem iteratively, but now the problem is how do you think about it and also implement it recursively. That's really the point. Let's look at some example here. So how many times does the character A appear in the empty string? Well, it should be a no-brainer, right? It should be 0 times, right? Because there's no way you can find any character in the empty string, let alone just A. Okay. And the second example, how many times does character A appear in a single character string? In that case, it will be just 1 time, right? How many times does character A appear in this single character string? Well, because A is not equal to B, in that case, 0 times. How many times does A appear in this particular string over here? Well, you can definitely count. It's going to be 1 time, 2 times, and also 3 times over here, right? Doesn't matter how you count, either from left to right or right to left. Doesn't matter. What about this? How many times does B occur in this particular string? Well, you can see it's going to be 1 time and also 2 times, right? So 2 times. And finally, how many times does C occur in this string over here? Well, does C even appear in this string? No, it doesn't. So it should be just 0. But now you can understand the examples very well. But how do you solve this problem here in general recursively? That's really the key, right? As usual, let me give you some visual hints, and then I will let you pause the video and think about how to sketch out the solution. Really take the time to really pause the video and think about what the solution might be. That'll be the best way to really push you towards understanding recursion completely, and also how to solve the problems creatively. Let's now go on to give you some hints. So far, we have solved 2 problems already, right? We talk about palindrome, we talk about reversal of the string, and now we want to talk about the number of occurrences in a single string. Let's take this string here, for example, right? Let's say this. Let's try to think about how many times does A appear in ABCA. Well, you can see it's going to be A and A over here, so that the number should be 2. What about, let me use a different color here. What about the number of occurrences of character B in this particular string? It's going to be just B over here, right? It would just be 1. All right. Well, apparently, if you want to solve the problem recursively, you have to know how to divide the input string into you want to decompose the string so that you can get some strictly smaller problem. The strictly smaller problem for the case of palindrome is simply just the middle string over here. And the strictly smaller problem to solve recursively for reversal is basically the tail of the string, everything except for the first one. But what about to count the number of occurrences? Let me give you some hints by describing what this 2 and 1 really came from. So that hopefully that will give you enough hints about how to really solve it, right? Let's say the case of 2. 2 is really equal to, I would say, 1 plus 1. I'll explain that what I really mean by this. And the 1 over here is can be really decomposed into 0 plus 1. Okay, so what do I mean? So here A, I want to maybe break it down into 2 parts over here. If A is equal to the first character A, so that will be already 1, occur already 1 time. B is not equal to A, in that case it will just be 0. What about the rest of the string over here? A appeared there for just 1 time, so that's why it's plus 1. And for B here, it appeared in the rest of the string just for 1 time, so that's plus 1. So this will be my hints for you. Alright, so pause the video and think about how you may program this solution recursively. Alright, assuming that you thought about it, so let me follow up with my hints before you pause the video. So what I really propose you do, propose that we do, is to break down the string into 2 parts. The first character over here, and also the remaining part for the character. And let me say the remaining part is BCD. So the way we breaks down the input string is similar to the reversal, but the way we make the recursive call is and also how to massage the recursive call result and also with other things to make the ultimate solution is different, right? Let's say this. You can think about this part over here. Let's say this part here is really about the number of occurrences in the first character, right? So basically, it's is the character equal to the head of the input string. And when I say the head, I mean the first character. So this is the head over here, right? If it is equal to, for example, A is equal to the head, so that's why it will just be 1. B is not equal to the head, A, in that case, it will just be 0. All right, that's kind of easy. So what about the second part? The second part is really the 1 and 1 over here. So this is really about the number of occurrences of the character in the tail of the input string. Okay, more precisely, you can take a look over here. You can see here 1 corresponds to how many times A appears in the tail of the string, which will be A only appear just A over here, right? Just the tail. And 1 here corresponds to how many times B appears in the tail of the string over here, which will be just over here, right? And given that, we will be able to solve the problem recursively. So the recursive call should really be invoked on this strictly smaller or strictly shorter substring, which contain everything but the first character. And we're going to add up these two numbers together. So that there will be the massaging operation we should do, which is just addition. All right, let's now take a look at the slide to see some written hints, and then we'll see how the code should really be understood and analyzed. So the base case will be just empty string. We got only one single base case. In the case of the empty string, can any character appear in the empty string? No, it cannot. So we'll always just return 0 in the case of the empty string for the input over here. All right. What about recursive case? For any string that's longer than the empty string, that means the length is larger than or equal to 1, we're going to break it down into two parts. Break it down into the head of the string and also the tail of the string. And in the case of the head, we want to know whether or not the input character over here is equal to the head. If it is equal to it, it will be 1. Otherwise, it's 0. Right? You can see it exactly over here. If it is equal to, if the character is equal to the first character, it's going to be 1. If the character is not equal to the head of the string, it's going to be 0. Right? That's exactly what we're talking about. And then going to calculate the number of occurrences of the character C, for example, this character here, in the tail of the string over here. So this is exactly the recursive call, because we are solving a strictly smaller problem by disregarding the first character, and then we're going to add it up together. All right. So that's kind of the formula, which I already explained. Let's now take a look at the Java code and let's try to understand it. Okay. So the Java code for occurrences of. Okay. And for this one here, you can see it's returning the number of occurrences integer, and then takes two inputs, the string and also character. But we're only going to create a sub-problems by making this input string strictly smaller whenever we make a recursive call. That's what we'll see. Only one single base case, right? You can think about this part over here is the base case. Just one. So this is the base case, when the input string is simply just empty. And this part over here is the recursive case, when the input string's length is larger than or equal to 1. So this part over here is a recursive case. So recursive case over here. Okay. Let's now take a look what's going to happen. Let's now also get some visualization for you. Let's say, for example, let's say this here, S, right? S is the input string. It's pointing to some array of characters conceptually. Okay. Let's say this. And let's say this is index 0, the first one, the first character, and then the rest over here. What we're doing is we are trying to get a head first. The head is going to be calculated. Let me just move it a little thicker. The head is going to be the first character by using character add. So this is the head over here. Okay, think about this part here is the head. And then what about the tail? The tail is going to be everything but the first character. So this part over here is the tail. And we are simply using the substring method to calculate it, right? We already talked about it. So this will be the tail. Okay. So this will be the tail. And then we got two cases to handle. Okay. And you can see it's either 1 or 0 over here, right? 1 or 0 correspond to the two examples we talked about, right? Over here. Either 1 or 0. You can review it. All right. Just to draw some connection. Either 1 or 0. And then, so either the character C over here, okay? So if C is equal to the head versus if the C is not equal to the head, right? So this will be the first part, okay? And this part over here, just the first part. And this will just be 1, and this will be 0, right? And we're going to solve the problem recursively over here. Let me move this one a little bit to here, just to make sure, okay, there's no confusion here. Okay. And then what about this part over here? And this part here is about the strictly smaller problem. And then we're simply going to make a recursive call. So now we are making two recursive calls, but not together, but conditionally. Either we go for this or we go for this. So this is not exactly the same as a Fibonacci case. If you recall the Fibonacci sequence example, where we also try to make two recursive calls, but those recursive calls ultimately should be executed both. But this one here is either this or this, depending on the condition for this. Okay, so this will be the occurrences of the tail and also C. So what we want to really calculate is to see the occurrences of the tail and also the character C. And then we're going to add up these two numbers together. So that'll be the ultimate result. All right. Let's now try to trace one string together, but maybe two strings. Let's see. Hopefully we can do two. Let's now just do these two together, shall we? Let's say A, B, C, A. Let's try to do A first. Okay, A, B, C, A. Okay. Let's say we try to do occurrences of, let me just put it here. Let me just OCC, just for short. Occurrences of A, B, C, A, and then character A. Right? I'm not putting the double quote or single quote. Okay. We're going to, first of all, break it down into two parts for the input string. Going to be this part here, and also BCA. Okay. And now in this case, we know that, let's say this. You can see A equals A. A equals A. So that means we're going to just have 1. Right? So that means we're going into this particular branch. Right? It's going to be 1. And then plus the recursive call result. The recursive call is going to be the occurrences of BCA, which is the tail over here, and then A over here. Please make sure you're okay with this. Having this original call to the occurrences of A, B, C, A with A. We can simply do, because A is the same as A here, so it's going to be 1. And then plus the recursive solution to the subproblem that's strictly smaller, right? Let's now take a look at how we can subdivide the problem further. Okay, you can see this one here, B is here. And what about the rest? The rest will be simply CA over here, right? So that part there is going to be, let's go further. So this part here is, we're going to compare A and also, let me say A and B. If you compare A and B, in this case, these two characters are not the same. So A is not equal to B. So that means we're going to use the 0. So that means we're going with this else condition here, with the 0 over here. And we're going to say it's going to be added to the recursive results. In that case, it's going to be CA. So we put it there. It's going to be the occurrences of the tail will be CA and then A. All right. Hopefully, so far you're still following. Let's now how to break it down further. C here, and then what about the tail? The tail will be, let me use maybe blue. A will be over here, right? That's a tail. And let's now execute it. So this will be C and A, they are not equal to each other. C is not equal to A. Or let me just always start with A. A is not equal to, let me just be consistent with the color. A is not equal to C, so that means we're going to have 0 for this. And what about the recursive call? Recursive call is going to actually look at how many times A will actually happen in this strictly smaller substring. Okay, so that'll be plus. So that'll be plus over here. And then we're going to have the occurrences of over here. That's going to be A in A. All right, so hopefully so far you're still following. We're getting there, but we're not quite in the base case just yet. Is this the base case though? Is this the base case? A single character string? Not really, because the only base case we have is when the string is actually empty. So we're not quite there yet. What's going to happen is we're going to just do one more. Okay. So if we want to do one more, let's say here. Okay, I gotta make sure I write a little bit smaller, right? Just to make sure I got enough space. In this case, the first character will just be A. What about the tail of the string? The tail of the string will just be empty in this case, right? So what I want you to really try calculating yourself is, in the case where, so let's say this. What if S is simply a single character string, let's say just A. In that case, what about the tail? It should just be an empty string, which we already spoke about in the earlier example. Let me show to you, right? That's something we spoke about earlier, right? I want you to look at that as well, right? So for this one, I'm going to rely on you to actually look at that, okay? All right, so let's now try to look at that. So we're going to compare A. Okay, before that, let me say one more thing. This is going to be purple. Let's say purple, the empty string will be the tail, right? So this will be the tail. And then we're going to do A compare with the head. A equals A. That's good. So this part here is going to be 1. And then what about the recursive part? And plus the occurrence of the tail will be just empty string. And then A over here. And this indeed is the base case. If you look at the occurrences of A inside empty string. So S is empty, right? You can see the S. Think about empty string over here is matching the S over here. That means this will be the base case to return. And this part here, what should we return that? It always returns 0. So this part here is going to be 0. Right? And then you want to look, so now we are going to get a series of returns from the stack. 0 plus 1 is going to give us the result for this particular occurrences of. How many times does A appears in A? In that case, it's going to be 0 plus 1. So that will be 1. So this part over here is going to be 1. Right? And then by adding 0 to 1 over here, we're going to get a result for this. Right? So this will be basically just 0 plus 1. So that will be 1. All right? Adding 0 to 1, we're going to get a result for the occurrences of A in BCA. And that one is going to be 1 over here, right? 0 plus 1. Finally, we can get 1 plus 1 is going to give us the result for the occurrences of A in ABCA. In that case, it's going to give us 2. So this is the final result. That's actually working. All right, so the routine is really working. So I think as an exercise, I would like you to try tracing this example over here. What about we want to see occurrences of B in ABCA? And you should really get a result 1. I'll let you trace it as an exercise. What's really happening over here, if you want to think a little bit sequentially, if I got ABCA, the recursive call is really the series of recursive call that goes in this direction is really trying to check whether or not A is really equal to each of the character over here. In this one, in this first character, A is equal to A, so we're gonna get 1. B is not equal to A, so we ignore. C is not equal to A, so we got 0. And A is actually equal to A. In that case, we get 1. So eventually we got 1 plus 1. Eventually. That's how you will solve it iteratively. I'm trying to draw some connection for you. But if you solve it recursively, you should really think about, we got the original string over here. We get something strictly smaller, another substring strictly smaller, another substring strictly smaller. Eventually we get to the empty string. And that'll be the base case to really return. And then we go directly return level by level over here, back to the original one. In that case, we can return because the call stack is actually empty. All right, so that's about the tracing for the occurrences of. Hopefully, you're also getting the idea. I would say for every of the 3 examples we spoke about so far, of course, you want to study the Java code, but I think the more important aspect would be how to break down the string. I want you to really revisit this particular page to think about how I actually describe the solution to you at a high level, because for any problem that's kind of similar to these, maybe something you haven't seen before, you will have to know how to break down the input string, either by getting rid of the first and last characters, or just by getting rid of the first character and get a tail, or maybe other ways to actually break down the strings into strictly smaller problems. So that'll be really up to your creativity to solve it. All right. So these are the 3 examples I would like to talk about for the recursions on strings. And that's the code we just went over. The next topic will be, I want to talk about how we can perform recursions on arrays.